Okay guys, hello, my name is Kay Davidson, and today I will be showing you guys how to balance chemical reactions. Okay, chemical reactions. Well, I mean, what are they? Let's start off there. There's molecules that bounce together with energy and they collide together and they form products like water in this equation here. Without chemical reactions, we would not have life. We wouldn't have pretty much anything almost. Like, we wouldn't even be here. I wouldn't be here describing you how to balance these. Okay, so now I know this looks a little bit messy, okay, at first. So let's walk through this. Reactions, right? So at first, we'll have our molecular hydrogen, right? This is a molecular hydrogen plus a molecular oxygen. And this is what we would call the reactant side, right? And then as the products here, we come out with oxygen, right? So at first, the chemical reactions first come out with a little bit of energy, right? And a little bit of energy makes out to a lot of energy. It balances out to that. So in our first one, we have a molecular hydrogen. That is 2, right? We have 2, which is a subscript of that. So now I've already balanced out this reaction here. So if you come over here, we take away these 2's, right? We take away those 2's. We just have we'd have a water compound. So we'd have H2O. So then we put 2 in front of that, and it comes out with total of 4 hydrogens, right? And we put 2 over here, 4 hydrogens. Because right here we have 2 oxygens. So we have to make 2 oxygens right here. Just imagine if that were 2 oxygens. And that balanced that equation out. Because over here we'd have 2 oxygens and 4 hydrogens. Because 2 times 2 equals 4. 2 times 2 equals 4. And we'd have a 2 here. And 2 oxygens here, 2 oxygens here. Bam. Okay, so now I wanted to try to make this as simple as I can. So here we'd have 1 and 2, and then make a molecular of hydrogen, right? And then another one, because we have 2 moleculars of hydrogen right here, right? Okay, so then over here we have a molecular of oxygen. Here's the 1 and the 2. That's a molecular of oxygen, okay? And now, in this case, we're not making or destroying any atoms or anything like that. We're not creating nor destroying. We're just separating these and then combining them together differently, right? So over here we have 1 oxygen, right? And we have 2 here, and then there's the second oxygen, right? And then here's 1 hydrogen, 2 hydrogens, 3 hydrogens, and 4 hydrogens, correct? Okay. Now this is very a reactive equation here. This is used for rocket fuel, or used to be anyways. I'm not sure if they do it anymore, but in rocket fuel they'd use liquid oxygen and then liquid hydrogen to produce a lot of energy. As you can see here, they just put a little bit of energy, and it makes a lot of energy and make rocket fuel. Okay, and I believe that's it just for starting out here. So let's move on to some more equations, okay? So over here, right, we have aluminum, and then we have a dioxide, okay, which creates aluminum oxide. So at first you'd be like, oh, okay, well, let's start out with aluminum, okay? So we have 2 aluminums over here. You'd be like, okay, well, let's put a 2 over here, right? Let's just say we put a 2. So we have 2 aluminums, 2 aluminums. And And you're like, okay, well, let's move on to oxygens, right? So we have 2 oxygens here and 3 oxygens here. Well, you could say, okay, well, how would we make 3 oxygens, right? Well, we can do 1.5 right here, which would make 1.5 times 2, which would equal 3. Well, chemical reactions don't really like that. So, can't really put a 1.5 there to make 3. So then we have to take out the 2 of the aluminum over here, right? So let's just say we put a 2 over here, okay, to make us 4 aluminum, okay. Well, now we have 4 aluminum, so let's put 4 aluminum over here. That takes care of aluminum, correct? So now 2 times 3 equals 6 oxygen. Okay, so 2 times 3, 3 times 2 over here makes 6 oxygen, right? So over here we have 4. Over here we have 6 oxygen. Okay, let's go over here. We have 4 aluminum, and then 2 times 3, 6 oxygen. So 4 aluminum, 6 oxygen, 6 oxygen. And now that equation is balanced. Okay, that one was pretty easy, right? Okay, so let's move on. Can you see? Okay, yeah, okay. So now we're going to move to a combustion reaction. Okay, so over here, carbon and hydrogen is an ethylene over here, which is a gas, and we have a dioxide, correct, which is a gas in this instance because it's a combustion reaction, so we put the gas over here, which equals, so reactants, products, which equals carbon dioxide, a gas, and then water, okay? So let's balance this out, okay? So we have 2 carbon and then 4 hydrogen over here. Okay, so let's get rid of the carbon first, right? So we have 2 carbon. Okay, so then we need 2 carbon over here. Let's just put a 2. Okay, so 2 carbon, right? So that makes that 4 oxygen right here. Okay, 4 oxygen. So then if we're doing nothing over here, so then let's take care of the oxygen, okay? So we took care of our carbons, right? 2 carbons, 2 carbons. Now let's take care of our hydrogens. Yeah, not oxygens, hydrogens first. Okay, so we have 4 hydrogens right here. And we have 2 hydrogens right here. So let's just do another 2 to make 4, right? 4 hydrogens. And then that 2 right there, which would make another 2 of the oxygen. So there's 2 oxygens right there. So now we have 2 oxygen. And then 4 oxygen right here. So that's 6 oxygen in total over here. And we only have 2 oxygens over here. So let's put it 3 here. And then that'll make that 6 oxygen over here. 2 times 3. So now we have 2 carbons, 4 hydrogen over here, and 6 oxygen. Okay, now let's go to the product side. 2 carbons, 4 oxygen, plus 2 oxygen over here, 6 oxygen, which equals that. And then we go over here, 4 hydrogens, 4 hydrogens. So that equation is balanced. Okay, now let's move on to a little bit of a tougher equation. Not that bad. It's just, you might get a little confused, okay? So over here on the reactant side, we have an iron oxide, and then a sulfuric acid, which equals on the product side a ferric sulfate, and then a water, okay? H2O. So now you might look at this and you'd be like, wow, like Okay, this is going to kind of get a little confusing just because of the sulfates, right? Got a sulfate here and a sulfate here. So, okay, how can we dumb this down a little bit without making this so confusing, right? So let's just rewrite this, okay? Just to kind of make it a little bit easier. Have our iron oxide plus sulfuric acid. Okay, so instead of this, the sulfates, right, I'm going to put in X just to make it easy. Just to make it easy. Okay, so X equals ferric sulfate with an X here, right? X to the third, right, down here. And then water, right? Okay, just to make it easy so we're not sitting here going, okay, well, 3 times 4 equals 12, and we have 3 sulfurs. Like, nah, it's just a little confusing that way. It takes a little bit longer, in my opinion. Okay, so let's take our iron. Let's get our iron settled here. Okay, well, we have 2 iron here, 2 iron here. Well, okay, that kind of takes care of that, right? So then let's move on to our oxygen, right? Well, we have 3 oxygen here, and then just 1 oxygen over here. Well, okay, how are we going to fix that? Well, let's... No, we don't want to do that. Hold on. We want to take care of our sulfates first, I think. I believe, right? Because we have 3 sulfates here, and we need 3 over here. Hold on. Okay, no, hold on. Let's take care of our oxygen. So we only have 3 here. Something ain't right here. Hold on. I think I messed this up. Okay, just hold on with me. Okay, so we're gonna go 4. Hold on. I messed this up. Oh, okay, there we go. I don't know why I thought that I messed this up. Okay. Anyway, scratch all that. Sorry about that, guys. Okay. So so we got iron here, 2 irons, 2 irons. Okay, blah, blah, blah. Let's move on to our sulfates here. Now, I know I'm kind of all over the place here, but we got 3 sulfates here, and then we got 1 sulfate here. So we need 3 sulfates. So that makes 6 hydrogen right here, right? 6 hydrogen, 3 sulfates, right? So that kind of takes care of that. So now we have 6 hydrogen here. And then 6 hydrogen here. So then we need to move on to our hydrogens over here, get our 6 hydrogens here, 3 oxygens right there, which would balance out this. I'm sorry about that, guys, before. Anyway, so we have 3 hydrogen, 2 iron. Okay, 2 hydrogen, 2 iron, 3 sulfates here. So this is balanced now. So we have 6 hydrogen here, 6 hydrogen here, balances that out. Let's just X that out. And we have 3 oxygen here, 3 oxygen here, 2 iron, 2 iron, 3 sulfates, 3 sulfates. Now that equation is balanced, so let's go up top here. 3 up here and 3 up here. and that balances that out.